No. So how?
Sure.
Yeah. Hey Prasad, can you just go there? We can see how is the go like. So which is the link now which we need to share link होता है ना एक. No, that is. Hey, can you the slide something on the? But we need to share this to people, na? Game stream आता ते बंद होईल. This link people need to know, right? That is not. Where is sharing? Hey, anyone knows how to share a YouTube live link? We've gone live, but how to share the link?
Hello? Okay. Is this good? Oh, is between me yelling and me talking on this? Okay. I think it'll be more clearer when we've got someone in the back.
इथून लाईव्ह केलंय ना आम्ही लॅपटॉपवर केलंय तर इथे ही लिंक हे करायची ना आपल्याला. हो पण लोकांना ते कसं कळणार आहे. हा मग ते त्याची लिंक असते. कॅन यू कॉल प्रशांत? नाही No, it is live now. Unless I send him the link and he sees, he will not be. Can you just get my this thing?
5 o'clock, yeah, he will be available. Call करा प्रशांत.
नहीं मला पर्स देना मी कॉल करते. अरे उस दिन हमने टेस्ट किया था. ती माझी ग्रीन पर्स देते का? ठीक है. तिथे खाली ठेवते. So now the thing is, people will not be able to sit here because it will obstruct. ही लिंक जोपर्यंत आपण लोकांना पब्लिश करत नाही ना, they cannot see.
चेक करना किती म्हणजे
लावलाय का? हॅलो.
Okay, thank you.
प्रसाद एक मिनट है. इट्स नॉट नहीं लग रहा. अगर लगा तो बोलना मुझे. हे आपण लाईव्ह गेलो पण ह्याची एक लिंक असते जी शेअर करायची असते जी आपल्याला सगळीकडे पब्लिश करायला पाहिजे की वी आर नाव लाईव्ह. ती लिंक कुठे मला दिसतच नाहीये.
शेअर लिंक
Create a channel, share your streaming link at least 48 before your social media during the before payment अपन नहीं करना.
I remember this year.
If you can like go to the
Sorry?
It says live. मी पण बघतोय मला माहिती आहे.
उस दिन हमने चेक किया था. नहीं, what is that?
Let's share, I think. So now you can share that link.
हाँ यही वो बोल रहा Now where all I need to share this link.
5:25. Give us just 5 minutes to start off.
WiMLDS.
What's in home rule for that?
So yeah, sorry. You're saying you're here for the AI bit, and you're just giving me some andas around what you already know about AI.
So Prasad, actually, there are a lot of people downstairs. Can you just wait for 5 minutes?
I'm just engaging these
Yeah,
guys
sure.
because they're early at the venue.
Yeah.
So this is some. So just tell me something about what you already know about AI, and it's perfectly okay if it's way off track of mine. I had a late flight from Bangalore yesterday, so I'm sort of looping. If you don't engage me enough, I'm just going to sleep off. You're not going to get much out of the session. So let's keep it in that. So I did get some answers from there that some students are currently pursuing their courses, but they'd love to see how they could create a business around AI. Some of them just want to see if they could pursue masters in AI or data science. Some answers from this section. Anyone?
I'm currently on data science. So I recently completed a certificate from IIM Bangalore with data analytics. I'm here to see how machine learning in AI can be implemented in real business environments. As a lot of challenges, there's a different inherent things that you know how to apply.
Hello.
Love to.
Hey, come. All of you come up.
I'm currently in corporate, but I'm thinking of starting up on my own. And for women, especially women's causes and children's causes, so I have business kind of in mind that I would like to implement AI and machine learning. That's where I'm doing my work.
That's great. Nice. Anyone from that? If no one raises a hand, I just randomly pick up, so I'm pretty good at that.
So, artificial intelligence is basically like analyzing the data, giving the intelligence to the system according to it. Like not writing 100 line of code, instead of that writing a 10 line of code from which analyzes the data and gives the output.
Okay. Nice. Alright. And then some from that section.
Which is the future.
I already love it. So, yeah, I think what you're saying is you cannot live without it in the future.
Hello.
Okay. So I remember this thing, and it's better to just say it now rather than when there's a full class. I was talking with a couple of people who were connecting me with some businesses who are invested in it. And the way they introduce me these days is so this is Prasad, and he has artificial intelligence. I do have some natural intelligence also, so it's so some of those things are fun when you sort of work in this field. I remember I met a gentleman who said, I want to use AI, and I said, sure, what's the key thing that you want to do? And he said, basically, he just gave me a whole lot of things he wanted to do. And at the end of it, I told him, well, if AI is going to do all of this, what are you going to do? Like, maybe just, watch him do it, but it basically had to do like 10 things, right? So, you started it?
Yeah, it's
Okay.
that's your Lakshman Resh.
Yeah, so Sucheta has given me this warning saying, I know you move around a lot, but don't you ever cross that line. So I'm sort of bound to this box now. I'll try and adhere to it as much as possible, but I might sort of sometimes need to. Yeah. Am I audible to the last step there? Can you hear me? Okay. So I'm not going to use the mic until I have to. So sometimes you sort of get that. So what they really wanted to do was everything. Figure out the outcomes of business meetings, figure out where to procure stuff from, what to procure stuff from, figure out the geopolitical situation, what's Trump going to do, what's this guy going to do, everything. And that was their notion of what AI is going to do. Right? So I'm glad I didn't get any of that from this class. So here we are ahead of the game right away. We're going to possibly wait for another 5 minutes, 2-3 minutes. Whenever Sucheta highlights the green signal, we can actually start off. Hello. Okay, in the meanwhile, let me set up. Until say tell me that I have to. Any better now? Yeah. You mean it's already cold, right? I faced that. When I said lower, people actually reduce the temperature. So, all right. So, I had a hard time actually coming up with this punchline because I wanted it to be genuine enough, but so like maybe under promise, over deliver, but yet make it catchy enough for you guys to sort of give me 2 hours of your life. Um, is it okay to start off, or are we waiting for more people?
I guess we can start fighting.
Okay, all right. So, can I start? Did Sucheta want to give an intro on? Yeah, that's the other thing she told me, so I'm just waiting on that. So you might have you actually seen some AI talks or read about AI articles, and have you already done that? How many of you guys have already done that? Okay, so about half of the audience. Good. How many of you are in the industry, like you work in the industry? 5, 4. College? Majority, okay, all right. Anyone who has their own business right now and looking to implement AI? 2, all right. Great. So you've got the whole spectrum. Do you guys code? How many of you code? Okay, quite a bit actually. Do you code AI? No, but you generally code. Okay. Can you just give me some languages that you code in?
Python,
Okay. Great. So you've got the whole spectrum from business users right up to college students, experienced folks, coders, non-coders. We're going to have fun bringing everyone on the same page and keeping them engaged. I'll try and do my best. Okay. So if you've seen a lot of AI videos and AI talks, what you'll figure out is that this is one thing that I sort of faced when I started off with trying to pick up AI. Most of them tell you, what's to be done, right? So someone says, I want to implement a neural net. They'll tell you some math behind it, and then they'll tell you what works, what doesn't work. But I haven't found very many resources that actually give you how to think about AI, right? And that's the key thing about demystifying AI. So what we want to learn today is give you the essential sort of toolkit that you go out, and then no matter what you come across, right? You might actually meet an AI practitioner, you might actually read about some AI stuff, you might read about research papers, right? But you will have the basic skills to sort of put two and two together. You won't know it all, but you'll know enough to have like an engaging conversation or an intellectual conversation with someone who's actively practicing AI, right? So that's the goal that I have. What I'm going to do is probably structure this such that we first look at the business aspects of AI, and that's going to be useful for everyone to develop that mindset. And then later on, we sort of might get into how do you just implement some stuff, and it's a lot of things to cover. So I'm going to try and see if I can do all of that. But if not, then we'll sort of have some offline session, and if we have some doubts, we can sort of clear that. Okay. So before we get into this, right, I'm going to show you a few slides, and I want you to tell me what do you make of it. Okay? Just 4 or 5 slides. No big deal. But I can tell you this. majority of what you will probably learn and use is covered in these 5 slides. Whether it's AI today, blockchain tomorrow, big data the day after, but these are going to stick around, right? So pay attention, at least on the first 5 slides. Okay, so who wants to go first? So this one says, is it clear enough for you? Okay. This one says all models are wrong, but some are useful. And there's George Box, who's was a British statistician, who sort of put that quote out, right? Just a quick thing. We don't want to spend too much time on these 5 slides, but just tell me, what do you think of it? Well, if things are wrong, why even use them? Accuracy. Okay.
It gives you insights. So not the very first model will give you the accuracy that you would want, but you will at least know this is not the way to go.
Okay. Anyone at the back? All models are wrong, but some are useful.
Learn from them.
Yeah. Or to get your job done, right? So they might not give you 100% accuracy, like I said. So you're not really looking for being right every time. But what you're saying is, it's going to save me time. I can extract some value. It's great. Let me use it, right? So that's the first one. I have a clip we probably play it later on. This is from a Hindi movie, 3 Idiots. Do you recollect this scene? Okay. What did you learn from it? Yeah. Okay. So you do remember. And why would we have it here? How many times have you read about AI and said, I don't know what this guy is trying to tell me? Or if you talk to someone and they define something in AI and you say, so what does that mean? And they'll explain it and in an even more difficult to understand jargon. And by 2 or 3 levels, you're like, okay, I don't want to learn about it, right? Have you faced it? I faced it a lot. You faced it too. So in this case, what we're going to do is, by the way, there were 2 guys here, right? One was trying to explain it with a lot of words and trying to cover every possible scenario, right? The other guy just said, what's the objective behind having machines, right? So there is a why have it, and then there is a what is it and how does it do stuff, right? So you want to make sure that this model is clear enough because I'm going to base a lot of the stuff to come on the Ancho method and not the Chatur method, right? Okay. How about this one? Does everyone know this? Yeah, okay. So it's about an elephant, and you've got lots and lots of people around, and depending on what part of the elephant they're sort of interacting with, they have an image of what's an elephant based on that, right? I'd like to sort of call it perspective or worldview, right? In the AI world, this is true of most new things, so emerging technologies, AI, blockchain. If you talk to people, depending on what they've been exposed to, they will give you a definition around that, okay? And confuse you even more in most cases, but so this is a good one to have. How about this one? For those guys who can't see it, it's one of those hotel room keys, and you won't have power until you sort of insert your key. But there is a hack there, right? And the hack is, if you know how this thing works, then you can sort of utilize your knowledge and get it working, right? So is it okay if you just call this hacking? Yeah, okay. Hacking is sort of a misunderstood term. Steve Jobs loved hacking, I think. The other bit is cracking, which most people call hacking, where you enter computers and do stuff, nasty stuff. But hacking was initially to try and figure out, with whatever resources you've got, how do you get to that objective, right? And more often than not, develop a more solid understanding of how things work. And the last one, the 80-20 rule. So is there anyone who doesn't? And I can go through it then. No, everyone does it. Okay. So what this says is, let's say you want 100% of results on something, right? Typically what happens is, post achieving the results, if you sort of go back and say, what actually got me most of the output, right? It's this 20% of something, right? The time that you put in, maybe you put in like 10 days, but in 2 days, you probably covered a lot more than the other 8 days. And those who are students would sort of appreciate this with our exams and the final day studies like the most important. So the 80-20 rule is 20% of your efforts will give you 80% of the results, right? So we are on the same page, we understand some of these models, and we know that all of them are wrong, but some of these could probably be useful. What's cool then is that's sort of the end of the talk. Because based on the 80-20 rule, the 80% of knowledge that you are supposed to cover from this session is already covered in 20% of the slides. Got you there. Okay, so based on these things, right, you can actually now go back, think about these. Sucheta will probably put these slides up. Go through each of these models to try and understand why is it useful in certain contexts, and then you'll be able to pick up AI on your own, right? But if you still want to sit through the talk, then I'm going to walk you through some stuff. So it was initially difficult for me to figure out how do I get everyone on the same page. So what I've done is just put in like a few levels, and if you already know stuff, please bear with us as a group, and we could sort of rush through stuff that most of you guys know. So the first one is, I don't know much about AI, but I'm an enthusiastic enough to actually spend my Friday evening with the class, right? So that's where we'll start. The next one is you know pretty much a lot about AI, no hands-on experience still, but you'll know the various terms that people use in the industry. The third one is where some of you said you would like to start off your own AI business or apply it in your workplace. So that's called an AI strategist, right? And we'll actually try and see how can we become one today. The AI 3 is basically a practitioner developer approach. Depending on the audience interest and if time permits, we can actually go into a few things there. And the final one is to get you to know enough for kickstarting your AI journey once you're out of the room. Okay? Sounds like a plan? With me? Yeah. Okay, good. So let's start off. I'm going to need a marker.
Yeah.
So instead of actually going through what the world currently does, right? What we're going to do is just wear our scientist hats for maybe 10-15 minutes or so, and go through an activity where we're going to cover all of these cases. Okay. For now, when you come into the room, forget about everything the world's doing. We don't care about who's doing what in AI. Let's say we just sort of collected a whole bunch of very smart people, put them in the room, and said, why don't you guys actually work on some of these things? Okay. So you have to help me here. What we're going to do is try and define AI, then try and create types of AI, build a humanoid, and then play some AI games, all in about 15-20 minutes. Okay, so let's start off with the definition of AI. Help me here. How do we define AI? All of these are questions. I'm telling you, I don't have answers for them. Let's build answers together. Okay, so okay, how do we go about defining artificial intelligence? The faster you give me answers, the more quickly we can sort of walk through this.
Making the machines think like us.
Making machines think like us. Okay, great. Okay, cognitive ability enhancement. Okay, anything else? Okay, help in decisions.
Sharing the skills of a human to machine.
Great. So transfer our skills to someone. So we're lazy enough, we don't have to work. That guy does the job. Then now.
Learning from mistakes, errors.
Sorry.
Learning from errors.
Handling errors. Okay. Yeah. Yeah. Humans make errors. Put in AI. So okay. So you remember the stuff that we sort of looked at on the mental models, and we said we're going to try and keep this simple, right? So no fancy stuff. If you want to define something, you try and break it up, right? So this thing has two parts. What do you think artificial means? Not natural?
When?
Yeah. Human made? Man, woman made. Human made? Yeah. It's WiMLDS. Yeah, sure. So, uh, human made. Awesome. Bang on target. What's intelligence?
Kind of automation on its own by machine.
Yeah, but automation is another jargon I don't understand. So, okay. 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 Good. So something that can actually learn and then use it, right? Is to say, "Hey, तो बहुत smart है. This guy is very smart, so he can sort of learn quickly, grasp quickly, pick up stuff, very intelligent, right?" Broad definitions. I'm not saying everything's technically correct, but I'll show you the technically correct part, and then let's see which one is easy to understand. Okay. So what we're saying is, if it's human-made, and it can sort of do something intelligent, like learn from something and use it for some, purpose, we would call it artificial intelligence, right? Good. Anything else we want to put in the definition? No? Okay. I will have a question for you later on this one, and it's about a calculator. Would you consider a calculator an AI? You can think about it. I don't give the answer right away. Okay, so great. A tick on the first one. Now let's create types of AI. How do you go about creating types of anything? Forget AI. Think about what types do you know, and think about how are they formed. Sorry, yeah, please be a little loud. So, variations, usability,
and method of how the skill can be.
Okay. Objective, great. Yeah. So, give me types of anything else. Forget AI. Right. So, types of fruits, maybe seasonal fruits and not the fruits that come throughout the year, or taste-wise. So you picked a dimension and you said, okay, so this dimension is what I'm going to sort of categorize them on, right? The jargon is dimension. It's basically just an attribute. You said, okay, so my way of classifying this is I'm going to say anything that is orange fruits, possibly citrus fruits, and then anything that's not is non-orange fruits. And that's a perfectly good way of classifying fruits for your objective, right? So depending on the worldview, the elephant that we saw, depending on what you're seeing, you might want to classify it in separate things, okay? With that knowledge, let's actually create types of AI. What do you think is a good reference of something intelligent? Yeah, what's the baseline? How can we sort of mark or grade intelligence? Do we have anything in this world that has intelligence that we can sort of compare it? Okay, so I really don't understand jargon. You have to dumb it down for me because I really don't get it. So please explain it to me. No, I'm just saying an entity that exhibits intelligence. Do you know of an entity that exhibits intelligence on this planet? Humans, right? We don't have anything else. Like if we knew 6 other races of aliens, we could possibly then categorize AI into, are they like that type or not? Right now, we're sort of stuck with just humans, right? So, what can you? How do we sort of create types of AI around this particular attribute or this particular dimension when you compare with humans? What are the 3 things that immediately come to your mind in terms of intelligence?
The way we learn.
Okay, even go simpler. Like I know what you're doing is about the what and the how. Give me the why. Like give me the essence of it. If you want to compare something with humans and classify it, what are you going to talk about these 3? Okay. Comparison. It's about comparison. So and this is really easy. Okay, so you're probably overthinking this. Either you are lesser intelligent than humans, or you are as intelligent as humans, or you're way more intelligent than humans, right? So that's one way to classify it. Do you agree? Okay, so let's actually go with that. And this is just our research study, right? We don't know what the world is doing, but this is what we think is a good way of classifying, right? What's the other thing? What if I tell you, task, do one task versus do any task, right? Can we create a class around that? Where how many times do we say, I'm really good at this, but I'm not good at all of those other things, right? As opposed to someone who's really, really good at everything. Okay, so that's one way of saying it. Are you sort of intelligent enough to do one specific task, or can you do a whole bunch of tasks depending on, you're sort of the superstar in your team, and people come to you for any problem that they've got, right? So listening, specific tasks, and then just generic intelligence that you can sort of apply anywhere, right? Now, in the AI world, you've sort of read about narrow and strong and weak. Have you heard about these terms? Okay, good. So we'll go through those. But essentially, what they're trying to do is something like this. Okay, if you are, lesser in terms of capability as compared to humans, you're one class. If you can do as well as humans, you're another class. And if you're way ahead, then you're the third class. Okay. By third class, I mean the third category. Okay, so now let's build a humanoid. Now that I sort of tell you all of this, we've covered the definition and the types. And you would be going bonkers saying, I hate this speaker, I don't know what I'm getting out of this. This is way too simple. I came here for the complex AI stuff. But stick with me for about 10-15 minutes. Once we actually go on to the next slide, you'll know how all of this nicely fits into what you want to learn. Okay, let's build a humanoid. So now let's say this is the 1950s. And someone comes in and says, we want to build something called artificial intelligence, right? And suddenly that's the first time the concept sort of is introduced, saying, hey, what if machines can actually think? And then the other guy says, oh, that's awesome. And what if machines can actually do stuff? And the third one says, oh, cool, then I'm going to get the machines to sort of do everything for me, right? So let's build that humanoid. Give me like around 5 or 10 things that you'd like. First of all, this is the 1950s. Give me something that you'd like the AI robot or the AI engine to sort of do for you, right? Ability-wise. So you could say, I'd love it to sort of see stuff, right? I'd love to sort of have an engine that can think, right? Or maybe just do tasks also, right? Driving, learning, teaching kids, cooking, whatever. So let's put down some tasks that you want, real quick.
Capture the memories.
Sorry?
Capture them.
Okay, so capture memories. I can tell you it can't do this right now. Okay, great. Cook. Great. Diving. Can't do. Go on. Cleaning. Okay. We're not there yet. Communicate. Okay.
Predict typos.
So communicate, we can't do it. Diagnose, way beyond. You can't communicate, forget about diagnosis. Okay, anything else?
Walk by itself.
Walk by itself. That's an awesome one, but sorry, you can't do. Finally, you'd be like, you know what? What can it do? Right? Because we're sort of ruling out everything. Right? We came up with this cool notion of AI can change the whole world and can sort of, be radical and transformational. And suddenly you're like, okay, technology-wise, data-wise, capability-wise, research-wise, we're not there, right? So what do we do next? What's the question that we ask when whatever we say, the research team says back saying, no, we can't do that right now. What do we do? Or we just say, okay, you tell me, yeah? How many times has this happened with you? Someone's saying, ye karo, wo karo, and finally you say, nahi, nahi, nahi. You say, abhe, kya karega? Like, what can you do? Then you reverse the question. When you reverse this question, I can give you something that it can do. Okay? And that's where I say, okay, so it can actually identify some patterns and maybe give you an output based on that. Okay? So now we start off with this whole thing, and that's sort of the grand AI goal. And very soon, maybe in about a few decades, we figure out we're not getting anywhere. So someone says, okay, let's try to get somewhere. And that's where they say, okay, so let's actually do this. It is sort of machine learning, right? So now you know AI and you know machine learning. Turns out that the way you do this, there are multiple ways of doing it. One of them allows you to be a little more lazy, right? Of course, the model that you create can actually learn stuff on its own. And then that part is called deep learning. We'll go in more details later, but for now, we just figured out that we wanted to build a humanoid. We couldn't get anywhere. We said, okay, so what can we do? Okay, we can do some stuff, maybe machine learning, and then from there, we actually figure out we can do much more, right? So expectations lowered, and now we sort of raise them up. That's it, right? So that's about that. The next one. So far with me, am I going too fast, slow? It's okay, right? Let's play some AI games. Okay, I need a couple of volunteers on this one. You can sit there and I'll stand here and it's okay. Or you could just come here and we could sort of play this game together. And it's an easy game. I'm not going to sort of get you difficult things to do. So can you tell me what do I write down here? 12, 3. So when you input 2, sorry, the output's 4. You input 3, 6, 4, 8, 5, 10, 6, 12. How did you get it? You looked at the pattern. Okay. What else did you? So when you say looked at the pattern, what are you really saying? Okay. Jargon. I told you I don't understand jargon. Input out. Yeah. Yeah. Okay. So you looked at inputs and you looked at the outputs, and you said, okay, so if I input 2, the output is 4. If I input 3, the output is 6. Right? And so on and so forth. And this thing is actually a gate called supervised learning. Do you know why you did supervised learning? Who's the supervisor here? We didn't have, I wasn't supervising for sure. The output was the supervisor, right? So you basically gave it an output to sort of look at. And in AI terms or ML terms, they call labels, right? So when you do this, suddenly you humans figure out, oh, I see the pattern here. So if you give me new stuff, I can actually tell you what's the output. I can predict stuff, right? And the AI models and machines typically do this. And it's sort of the most popularly practiced form right now in AI, right? Okay, so all good with this? Let's move on to the next game. This time I'm actually going to draw out stuff, and I need you to sort of separate them out, okay? Would you do that for me? Yeah, okay. So I have only 2 colors, so I'm just going to do 2 things. Can you see this at the back? Okay, you can't. All right, so imagine. So let's say I have a whole bunch of orange dots, and I have a whole bunch of red dots, and a whole bunch of green dots, right? And I ask you to separate them into groups. How are you going to do it? Based on color, okay. So what would you do? Like, you would basically give in the orange one somewhere here, and the red ones somewhere here, and maybe the green ones somewhere here. What you're saying is, Prasad, I'm going to sort of say I have 3 groups, right? Now this is just based on your observation of what was given. Did I give you the labels like last time? I did not, okay? So it is not supervised. So what do you call something that's not supervised? Okay, good. So whenever someone says we're doing unsupervised learning, what they really mean is they don't know what they're doing. As in, the labels aren't there. They're trying to figure out what's happening, and unsupervised thing is a pretty good tool to actually use in some cases. Okay. All right. You guys are very fast actually. I thought this would take a lot of time, but you're getting the hang of this, right? Okay. The third one. Have you played the hot and cold game? I'm guessing you have. Huh? Someone hides some. No, you haven't. Okay. So let's do it. Okay. So let's say. How do I do it? Okay, I won't do this, but you have to imagine, okay, just visualize. So let's say this is where I want to reach, okay? And I stand here, and I close my eyes, and someone just sort of rotates me around, and then I'm in this position. I have no clue of what is where, okay? And now I want you guys to help me out reach that pen. And I'm opening my eyes, but you can assume that I'm closing because I don't want to mess up on this. So if I actually move forward, and you say cold, right, or negative, don't do that. I might fall, right? And then when I say, okay, so bad move, okay, can I go this way? And you say, yeah, good. So this is good, okay. So you're sort of reinforcing positive behavior where you want me to sort of go, and I eventually go step by step. If I sort of go back, you're like, no, this is bad. So okay, this is good, okay. So I keep trying out various things, and eventually I sort of reach this, and I was like, yeah, okay, thank you. Okay, what you did was you reinforced, positive behavior to achieve that goal, right? And that's called reinforcement learning. Okay, all right, fine. Was that 10 minutes, 15 minutes? Not right? Yeah. Okay, good. So let's actually go through this stuff. Now you know all of these, right? We defined what is AI. We classified it. We built our humanoid. And then we played some AI games. We don't know what they are yet, but let's see. That's how the world defines AI. This is on Wikipedia, so by world I mean. And before I read this, I think, do we have the audio? Can I play a clip or?
I hope you're testing.
I'm just going to try and see if I can play this.
What is a machine? So, a machine is anything that reduces human efforts. Definition क्या है? Sir, कोई तो बताओ sir. Anybody else? Yes.
Sir, machines are any combination of bodies so connected that their relative motions are constrained, and by which means force and motion may be transmitted and modified as a screw in its nut, or a lever arranged to turn about a fulcrum, or a pulley about its pivot, etc. Especially in construction, more or less complex, consisting of a combination of moving parts or simple mechanical elements such as wheels, levers, gears, etc.
यार, लेकिन सर मतलब भी तो समझ आना चाहिए। ऐसे किताबी डेफिनेशन रट के क्या फायदा?
I played some portions to make it short.
So we were discussing about the machine. अरे, तुम वापस क्या आए हो? सर कुछ भूल गया सर। क्या? Instruments that record, analyze, summarize, organize, debate, and explain information by illustrative, non-illustrative, hardbound, paperback, jacketed, non-jacketed, with forward introduction, table of contents, and things that are intended for the enlightenment, understanding, enrichment, enhancement, and education of human brains to sincere provision, sometimes touch. अरे कहना क्या चाहते हो? किताबें तो सीधा सीधा नहीं कह सकते। थोड़ी देर पहले कोशिश की थी सर, लेकिन आपको सीधा सीधा पसंद नहीं आया।
Okay, cool. There was a reason why I showed you that right now. I'm going to define artificial intelligence as per the outside world now. Okay. The theory and development of computer systems able to perform tasks normally requiring human intelligence, such as visual perception, speech recognition, decision making, and translation between languages. The next definition out here, it says study of intelligent agents and device that perceives its environment and takes actions that maximize its chance of successfully achieving its goals. Colloquially is applied when the machine mimics cognitive functions that humans associated with other human minds, such as learning and problem solving. See the relation? Okay. Now I'm not saying this one's not cool and the other one is. What I'm saying is when you read some stuff like this, these guys are trying to be nice. They're trying to tell you the what and the how, right? It's saying, what do you mean by that? Cover it in all angles possible. But for someone who's just entering AI, it can be sort of intimidating. Like, kitna bata rahe, nahi ho raha, right? So things like that. So when you read some stuff like that, it's okay. Just try and figure out what's the why, right? What is the key thing there? And in this case, you can just remember artificial is sort of human-made, and intelligence is the ability to acquire and apply knowledge and skills, very similar to what we worked out, right? So it's sort of as good as the guys outside. Types of AI. What I've done is I've used some images, and it's sort of a trend throughout this topic, and I've put in sources there. So in case you want to go and look more, study some stuff, you could do that. So the first one says strong AI versus weak AI. Okay, strong AI, as good as humans, can actually do stuff independent of the task. Right? You give it some task, it can do that. Give it another task, it could do that as well. Weak AI, also called narrow AI, it says, oh, don't confuse me. Give me one thing, and that's the thing I'll do it. Right? So that's weak AI. The next one, so remember, this is the world trying to attack AI simultaneously. Right? So when someone built something called strong versus weak, someone else sort of talked about narrow versus general versus super. Or even better, they said narrow versus general. Right? And then someone else said, hey, why not super? Why limit to humans? Right? And those are the three things that we also worked out. So we're actually pretty smart. Right? Where we said ANI is sort of lesser than humans and on a specific task. AGI is general intelligence like humans. And then ASI, super intelligence. Would we know what that is? Would you know what is super intelligence? It's something way beyond human comprehension. So I don't even know what that is, but classifying, right? We could always classify. So that's about the types. Now coming down to this big confusion around what's AI, what's machine learning, what's deep learning, right? NVIDIA has got a great post on that. You sort of go and read that. And it says early AI stirs excitement. And you're like, okay, AI can actually do everything in the world. And then they sort of get realistic, say, okay, maybe machine learning can do some stuff that's useful to us. And finally now deep learning with all of the new computing power and the data set and stuff like that can actually get you much more than traditional machine learning, right? So that's sort of the way things actually are. This is easy to understand, right? It's sort of a superset and then a subset and a subset, right? I was planning to do Venn diagrams, but then I said, I don't know if that's a good idea. Someone else actually defined this in a pretty neat way, and I'm just going to read this up. So this one says, AI, this work is really tedious, yet requires a lot of troubleshooting and problem solving. So maybe a machine could do it for me. The vision initially that we worked on. Then you go to the next one, says, it's really difficult to program this computer, and we're calling it intelligent, but it is really difficult to program the computer to understand what I need it to do. Okay, I cannot really figure out how do I teach AI. I don't know how to sort of build all of the rules of that logic that I want it to do, right? So it says maybe it can just teach itself if I just show it good examples and I give it some structure, learn by this way. So that's machine learning. And then when you come down to deep learning, it says, I don't know how to make this computer understand. Maybe it can create its own structure. Like I don't even want to do the structuring bit. So deep learning helps you to just sort of, start it off and it's going to learn on its own. Okay, so that's sort of the difference between the three. Now, there's a great library. Everyone understands a library. Anyone does not? Computer libraries are code that's already built and put up, and you could just directly use them. It's sort of reusable stuff, right? Okay, so these guys classify it really nicely. So, and this has been there since AI became popular, right? Before that. So machine learning sort of has three main branches out here. Supervised, you remember our game? Okay. Unsupervised, the game again. And reinforcement, where you guys were getting me to trip. Yeah, okay. So those are like the three main types of ML or AI. Now you know if I say ML or AI interchangeably, what I mean by that in that given context. Okay? Good. Fair enough. And according to me, you now are well informed. Okay, let's test this. I read something in the news today that said people were actually doing some cancer research, and they have a lot of scans. And based on the scans, they sort of have scans which have cancer and scans which do not have cancer, right? And they're training AI to sort of learn to detect cancer from a scan. What type of AI is this? What sort of supervised? Okay, great. If I give you a whole bunch of news articles, right, and I say I don't know what the news are about, okay, try and just group them in some way which sort of seems cohesive, like all articles of a topic somehow sort of get together into one group or cluster, as the jargon is. What would you call this? Unsupervised, great. And the third one, well, this is a no-brainer because it's going to be reinforcement learning. But have you heard about how some of the top AI teams built some games, or sort of some engine that would play games, and they beat the world's champion, right? So, do you think that is reinforcement learning? Okay, I'll tell you how. Start off a computer or an AI engine to sort of play games with the environment and make some moves. So if it's chess, let's keep it to chess instead of Go or poker. So if it's chess, right? Get the guy to play games and he loses, wins, loses. Eventually, it sort of learns how to beat the opponent. Eventually, it sort of learns how to go to the mark, right? Positive reinforcement. So most of the stuff around reinforcement learning right now, at least based on what I know, is it's sort of restricted to those areas because you can just spawn off, a million game instances, right? So if you've got a program with that environment, the 3D environment, and you just get the computer to play with itself, you can just keep playing while we spend our Sunday, Monday, that month, next month. It can just keep going on, right? However, if you have to look at patients that way, if you get a patient, right, and you say, I need the patient to live 10,000 lives. In some, it will have cancer. In some, we won't have cancer. And then I study stuff. It's difficult to do, right? So reinforcement learning sort of works great with some of these gaming environments because you could really learn a lot. So that's why they sort of tie it. I'm pretty sure eventually they'll find a way of getting it into the real world. Yeah, there might actually be some instances already, but the real power lies in sort of reinforcing that over a whole bunch of tries. Okay, so good. So I asked you a question and you got it. That's awesome. How are we doing on time? Just check here. Okay, cool. So the next part, right? We talked about the first one. You don't have to do much about it. You just had to come here and you were at level 1. Now we're at AI 1, which is we sort of know all of this stuff. We know types. If people talk to us about AI, machine learning, deep learning, it wouldn't be as confusing. If they just talk about AI, we know what they mean when they're sort of giving us a lot of jargon and definitions. But now we sort of, based on that, based on a new level of understanding, now we're going to try and see how do we spot AI opportunities, right? And this is where some of you who are interested in business, right, could actually use what we're going to discuss today and head back and maybe spawn off your own startup. Or if you work at some place, you could start using AI there. Or if you're a student, you could pick up an AI project that you're interested in. So it's always good to have this skill of like a strategist sort of spot how do you leverage AI, right? So for that, what I'm saying is the most important task here is this piece, and we have to work this out together. What I'm doing is giving you a magic box, okay? So let's consider all of us, irrespective of our coding expertise or our tech exposure. Let's say we are business folks and we want to really understand how do we leverage AI, right? For that, let's consider a black box, and it's an AI box, okay? You can basically learn stuff if you give it an input and tell it what the output is, right? So the whole X to Y thing. So what are some ways of doing this, right? And I'm doing actually has a great video on that. We'll have it in the resource, so you should go check that out. So here are some examples. I'm just sort of putting them up so that it is a good warm-up, and then we'll discuss a few of our own that are relevant to you guys in your field, okay? So the first one is if you input a picture, and if you sort of are looking for human faces, right? So yes, no, right? You put in an image and say, well, there is a person in this. Put another image and say, there is no person in this. And if you have like a whole bunch of these, the magic box is going to sort of learn that, right? And suddenly you have photo tagging capability, right? What you could next do is give in lots of images of Prasad and say, this is Prasad. And give in lots of images of Sucheta and say, this is Sucheta, right? So then it's sort of identifying the person as well, right? With that same AI box. The next one, loan applications. If I give you a whole bunch of information around who's applying, and I tell you whether this person defaulted or didn't, right? And I have lots and lots of data for the last 5 years, 10 years. Can you build a model that can then actually help me in loan approvals? Yeah? Because it's going to then learn what sort of parameters do the guys who pay on time have versus the guys who don't pay on time have, right? So that's another great example. The third one is, this is where you sort of see all of these ads, and the guys who post those ads want you to click on them, and they can actually do a lot of profiling. So they could sort of look at ads plus user information, and if I have a whole bunch of them and who clicked and who didn't, then you have targeted online ads, right? So on and so forth. I won't go through the whole thing, but you get the drift. Now let's actually work on a few of, maybe 3 or 4 of your problems. What you could do is just raise your hand, give me a vertical, right? So healthcare, retail, e-commerce, whatever you want to work in. And let's try and find out what are examples that you could apply AI. Okay? Anyone? Or I'll just start off with healthcare. Yeah. Telecom. Okay. So let's actually see if we could build AI for telecom. So in this, what sort of data do you have, and what sort of decisions do you make? Okay. Okay, great. Okay. So what you're saying is, I want to see if I have, let's say, 1 million customers. I want to see which ones will actually end up buying my value-added services. Okay. Can someone tell me what do you need on this? What sort of data do you need for this? Yeah. So you have this data. What sort of labels do you need now? Yeah. Did they buy a value-added service or did they not? Right? So then you have all of this data and you say, okay, this guy bought, this guy didn't, this guy bought, this guy didn't, and so on and so forth. And now suddenly you've trained a world-class model that can actually suggest whom to target for value-added services. Right? Okay, another example. This doesn't have to be industry. I can tell you a lot of applications in schools and colleges as well. So just pick something. And is there anyone from HR here? Okay, yeah. Can you think of recruitment? Okay. Okay, so I need someone to sort of specify the input and output here for me.
Whether a candidate will accept.
Okay, great. So offer acceptance model. Some of them did, some of them didn't, and now I have a model I can train. The next time I'm offering one of 50 guys, I know which ones might possibly buy it. Okay, anything else? That. Okay, all right. So that's the other one here. So before we go there, on the HR space or the recruitment space, what are some other things you could do? Attrition, right? So you could build models for attrition. Basically, look at your last 5-10 years, try and say these guys with this performance sort of left me in this much duration. Now the new guys coming in, can I have a model? All models are wrong, but some are useful. Okay, so don't go after the guy that it predicts is going to leave you and say, why are you leaving me? The poor guy might not be leaving you, but okay. So and that's just one, right? There's a lot of stuff: recruitment, attrition, performance. You could do a whole bunch of things. Okay, so let's go to disaster management. Someone there say disaster management. Yeah. Okay. So what's the use case? Great. Okay. So what sort of data do you need on the input and the output? Yes. Okay. So previous data on, let's say, the weather. I'm not a geo guy, but I think there are some seismic activity that they record. So all of that, and then you said, in such instances there was an earthquake. In such instances there wasn't. Now with these instances, can we actually predict what's going to happen? Great. You guys are coming up with fancy stuff, man. Okay. Anything else? You want? Sorry. Electoral system. Electoral system. Okay. Have you heard of Cambridge Analytica? Oh, you wanted me to go there. So I'm on live stream. So the way you do electoral systems, okay, let's just take that as an X and Y. How do you do it? First of all, the politically correct one. I'm just going to try and figure out who's going to vote, who's not going to vote, right? Like try and figure out a model where I have a lot of information about my citizens. I say this resulted in this guy voting, this resulted in this guy not voting. If I have previous electoral results, right? And then what you have is a model that's going to predict what pockets are going to vote in what percentage, and wherever it's low, you sort of engage them proactively and say, please go and vote, right? So that's one model. Coming to the more political one, which you are targeting, obviously, was so. What you could do here is, I don't know, what was the question? Like, what sort of model? What's the objective you want? Who's going to win? Okay, so let's say for the previous 3 or 4 elections, you've got a lot of data around something. I don't know what that something is, but let's figure out, right? So you say, oh, I had a whole bunch of this data, and this resulted in party 1 winning. And I had a whole bunch of this data, and this resulted in party 2 winning. So on and so forth, right? You could then build a model for this time, what's the condition here? It could be social media, it could be polls, it could be just going and doing surveys, and then based on all that data, you sort of construct this, right? So AI could help you there too. You know what happened with Cambridge Analytica? Okay, cool. We should probably take that offline as well, in case you're interested to go into details. Okay, so by now you've got a fair sense of how do you apply AI? Is that yes or no? Because this is the most important part. If you don't get it yet, I'm going to wait on this until you are comfortable with it, because this is the ROI I'm looking for. Like once you go back, I want you to sort of figure out where do I apply AI, and trust me, once you figure that bit out, going about applying AI it's not trivial, but not that difficult, as opposed to not even knowing that you could possibly apply AI there, right? So the other bit I wanted to highlight here was the input doesn't have to be numbers, right? What else could it be? Yeah, I shouldn't have put up this slide, but yeah, sort of gave it away. Okay, but what else other than images and text? Speech, audio, right? So now what you're saying is, look, I don't know how to sort of do this, but I know that the input types are these. I have text, I have numbers, I have images, I have videos, but videos are basically just slices of images put together, right? You've got about frames per second, and basically just a whole bunch of images, put them together, and the video plays out. But I'll write down video as well. So video, speech, and this thing sort of keeps going on, right? What's the output? We talked about yes, no, but what else? So when you sort of do a yes, no, they call it a classifier, right? If it's just 2, the geeky language is binary. Some students right now, so it's called a binary classifier. But if you have multiple classes, what would you call it? Multi-class. Fair enough, right? So that's how you sort of bust jargon. Okay, what's sort of the other stuff that you could have on outputs? Can I predict the value of something, right? So when you're doing predictions of classes, classification, and this is where the model breaks, okay? And if you're doing a lot of numbers, it's not numberification. They call it regression, right? So so that's where our jargon busting method doesn't work. For some reason, it's called regression, and that's it. So whenever you're dealing with numbers or outputting, what's the expected salary of a particular individual? That's where you need numbers there. How much would this particular house sell for? Numbers again. So that's where you sort of go into regression. But if it's just classification, and there's a lot of application on classification itself, you could do yes, no, or you could do multi-class. Can someone give me a good example of multi-class? Let's say if it's cancer, right? What's multi-class there? So binary is yes, no. Does the patient have cancer or no? Stage of cancer, type of cancer, right? So depending on your objective, you could sort of say, okay, I'm interested in figuring out the stage of cancer. So you bring a lot of data with some with stage 1, some with stage 2, some terminally ill, and then based on that, create a model that can put it into one of these buckets. Make sure you also have another bucket for no cancer, because otherwise any input that comes, it's going to put it into these three stages, right? And then you'll blame the model. So, and then on top of that, you'll say, hey, it's artificially intelligent, like intelligent, it should have done that. It won't do that. It's sort of dumb in that sense. You've got to leverage it for what it is. So always think of that none of the above case, because it's pretty useful when you model out in practice. Okay, so based on this, I'll just put in a few examples there, and we walked through a few things like HR, like disaster management, politics, whatnot, and you have a good idea, I'm guessing, about how you go about finding these opportunities, right? Can we move on? Do you want to do some more examples, or are we good? Okay, awesome. Smart bunch. Smarter than me, I took more time. This takes us to AI 2. Congratulations, you guys are now qualified to become strategists around. How do you go about this? Go to any company that you know and say, hey, you know what? I'm sort of a budding AI strategist. I've worked out, AI in 6 different domains. What's your domain? And can I sort of suggest some stuff where AI is useful? Right? Trust me, go and do this. Get some real world experience. And people would say, really? Are you kidding me? Okay, this is my problem, or this is my industry. Even better, go and work out. If you're going to meet someone from manufacturing, go and work out 3 or 4 cases and say, does any of this apply to you? And maybe we could just help you with AI. That's pretty much what we do. Okay, so the next one, so this section was a little tricky for me to build, because this is the practitioner / developer section, and I wasn't sure about how many of you guys code and what sort of basics you covered. So what I'm going to do is walk you through some stuff at some sort of level. It's not very high level, you'll still get to see some code, but based on what I've gathered, I'll probably keep it light there, and then if you have specific questions, we'll take it off. Fair enough? Okay, so what's the typical process? So now when we started off, right, we said we know something about AI. Then we sort of figured out, okay, we are well informed. Then we moved on to say, now we know how to use AI, right? But when you actually go and build all of this stuff, we left out a big loophole here, right? Like the main piece here. What's going to go here? That's going to do this, right? So this is the piece now. We're talking about what's a typical AI process, how do you go about it, and what do AI practitioners do. We won't cover it all, obviously, but this thing will have enough building blocks for you to go back and then study from whatever resource you want. I've listed a few as well, and that will really kickstart like the coding journey. Okay, so typically what you do here is, you know what? Instead of this, just tell me what you would do, right? I know it. Again, I keep doing this. I just keep showing you stuff and then asking you the same thing. But let's figure out how would you go about building this out. First, you need the data. Can't do much without that. So you want to collect data. Okay. Now, more often than not, when you collect stuff, it's not in the format that you need. So what do? Clean it up. Okay. So we call it pre-processing. Like pre-processing because it's not the main stage. So previous to that, it's pre-processing. There might be something which is post-processing as well. So first is you sort of collect your data. The next one is sort of pre-process, clean, do whatever you want. Then what do we do? Now's the main part. Like the AI model has to come somewhere, right? Like you cannot just beat around the bush. At some point in time, you have to talk about the AI model. So once you have this prepared, then you sort of construct some AI model, and then you say, look, this is my input, and this is my output. Okay, and train on it. Okay? So that's the training part. After you train, what do? How do you know if it's good or not? Yeah, so you test it, right? So test, or you could sort of say, I'm going to evaluate this. If it's not good, go back, change things, and do it again. If it is good, what do? Your AI model is ready. Deploy it to whatever application you want to use, right? So we constructed this too. And that's what people do typically, right? So you'll fetch, clean, prepare because the AI model needs it in a certain way. If you heard about matrices and tensors and but basically some way that the AI model is expecting it to. Then you train it, evaluate the model, deploy it, and then you keep monitoring, you get more data, train it, train on the extra data as well. And that's how you sort of go about doing it. What I'm going to do now is show you like a quick demo. I know this is like an AI thing, and most people expect a lot of demos, but I thought instead of giving you demos, I'll give you the tools to sort of understand any demo that comes your way now on, right? So which is why we focused a lot on getting the basics first, and now no matter what this is, we could sort of figure things out. So this is a website that's actually used, there's a library called Keras, and someone's ported it to work on browsers, and I thought this was really nifty because we could just use stuff here. Within this space out here, I'm going to draw any digit between 0 and 9, and the AI model is supposed to figure out. Can you tell me where is this useful? Like if I just give me a number so that it's not canned, like it's not like I'm going to put in a 7 and it knows 7. Just give me a number and 6. Okay. So it got 6. Okay. So handwriting recognition, right? Number recognition, digit recognition. So one of the basic things, like any data scientist or AI guy would tell you, is something called MNIST. It's a data set with lots and lots of these numbers put up. The postal guys have to use it to read stuff, right? Because a lot of guys will put in PIN codes and it's all handwritten. How do you figure it out? So you can automate some of that if you've got this capability, right? And what you see below that is a whole bunch of neural network layer visualizations on what's happening under the hood. And it's, basically things flow through it, and eventually you see this guy down below there, that's 6. Like if we talked about the output, so imagine the output going from 0 to 9. From 0 to 9, and it's highlighted 6 here, right? Stages of cancer, no cancer, and then highlights the one that is supposed to be the output. So that's how it's predicting, right? Do you want to try another example? Maybe 2. Yeah, works. Again, it won't work it's a good thing to go and play with this and figure out how to break it. Like write down something which seems possible to read humanly, but not through this guy, right? So you're trying to break that stuff. So the reason I wanted to show you this is because I want to actually show you code on how to do this exact piece, right? So there are lots and lots of libraries, right? You've heard about TensorFlow, which is like Google. Similarly, all of the biggies have their own libraries, and you could use any one of them. And Keras sort of is an abstraction layer on top of that, on some of them that works. So we personally use Keras, but it's not that one's better than the other. Just go and play with whatever you're comfortable with, and then you sort of see how things work out. Okay, so we're just quickly going to go through this part. Some configuration and then imports, like all of that core functionality is sort of put up in some library somewhere, Google's library, Facebook's library, right? So you want to bring that functionality and be able to sort of use it. So all of those are imports. For the guys who already know Python, please bear with me. I'm just making sure everyone understands this. This will be really easy for you guys so basically they're just imports right now. After that, you're saying number of classes, 10. You're interested in 0 to 9, right? So that's where you specify. Is this clear, or should I just increase the font a bit? Yeah, okay. So you try and figure out that, then you specify what is the input. The image is going to have 28 by 28 pixels, right? So that's going to be the input here. You remember how we said the input can be anything? Yeah, I left out a small detail there, I'm sorry for that, but that's because you need to understand this part for that, so which is why I sort of left it for later. What you need to do is the computer model will not understand anything but numbers. So no matter what your inputs are, you have to have some way of getting them to numbers. Once it's in numbers, AI is sort of cool there. It can actually play with all of those numbers, right? So in images, what's a good way of representing them in numbers? The pixel values, right? If you take an image, the computer representation has pixel values and RGB channels, so that's how they use it. Now imagine if I give you text, right? So people who do images and they do a lot of this AI stuff, they say we work in computer vision. like they're teaching computers to see, right? People who work in text will say you're doing natural language processing, right? So when you go and check out all of this, right, you're like, okay, this is way too vast for me to get. But now you get it really easily because you know that all of them are inputs, right? And somehow they'll map it to numbers. The computer vision guys take RGB channels and pixels and map it to numbers. The language guys convert text into things like word embeddings, and there are various things, right? For example, if you actually note down words and you note down documents, and you say, how many times did this word occur in this document? You have a number there. Now you sort of fill the whole thing, and now you have enough numbers to feed it, right? So those are some basic things in which you can sort of convert text into, again, the stuff that you want here, okay? So don't get bogged down with natural language processing, computer vision, there's speech recognition. Basically, all they're trying to do is how do we come from that space, put it to some numbers, and from there on it's the same process, okay? So in this case, that's what it's doing. It's doing the shape thing here, saying 28 by 28. After that, logical question. If I actually get you, so let's say you have some cases, right? So let's say you have 100 photos of cats and 100 photos of dogs, and you want to sort of develop a classifier that identifies cats versus dogs. Now, would you give all 100 to the model to train on? No. Why not? Yeah, how will you test it? Right? It's like cheating. Like it's already seen the exam papers, and now you say, perform on this, and it's got 100% accuracy. You go and tell your boss saying, awesome, I have like 100% accuracy model. You put it in production, boom, fails. Right? Why does that happen? Yeah, it's already seen just those. And we'll talk a bit about overfitting and underfitting. Like that's a concept that we'll figure out. But it's just seen those, you tested it again on those rather than things that it shouldn't have seen during the training. So that's where typically what happens is you sort of split into three parts. One's called the training set, the other one's the test set, which is clear enough, right? Train, test. However, during training, the model says, hey, am I doing okay? It has to ask someone or test against some images, right? Saying, okay, am I doing okay? If not, it's going to correct course, right? So that's sort of a validation set. So when you talk to some guys, they'll be like, oh, I don't know how much should I put in my training set, and how much do I keep in my validation set, and how much do I put in my test set? That's what they're trying to figure out. Typically, 70-80% of it might actually go in your train set, then maybe another 10% here and another 20% there, right? No hard and fast rule, play with it and you'll figure out. But now you know what those three terms mean and why is it that you need a different test. Okay, so that's what this guy is doing. The other funny thing here is / equals 255, right? Any guesses on what that is? Okay. So let me give you a question, and you tell me how are you going to solve it. Is this going to be visible if I write? Can I just take this off? Yeah. Okay. So let's say I have two inputs. Okay. So this is my model. The data that I have is attributes. We said attributes. Let's call them features because that's the jargon. Okay. So let's say feature 1, feature 2, and then that's my label. Okay. So this could be anything. So let's say, okay. So let's pick up oranges and apples, right? So stuff that we pick. So let's say this was some orange one. That's an ID, right? That's the image. And the first one is basically just the RGB values here. And this is some sweetness factor in 0 to 2 or 0 to 3. Okay? So what I'm saying is, and I'm not giving you a great example, but I'll tell you what I really want to say. So let's say this feature can range from 1 right up to, let's say, 10,000. RGB values don't go that big, but yeah. So let's say this can actually take values between a large range. Okay? And then the other one actually takes values between 0 and 0.3, like a very small range. Okay? Now the problem here is these are varying parameters, like varying features, right? So what you really want is to bring them to the same scale somehow, right? So it's easy for but without getting into technical, it's easy for the model to learn if you just bring everything in the same scale, right? And one way to do that is just bring everything between 0 and 1, right? So it can vary only 1 unit, no matter what its field or the actual case is, you just bring it down to 0 and 1. Okay, so that process is called normalization, and that's what this guy is doing. Like you could vary from 0 to 255, just divide by 255, and suddenly you will vary only from 0 to 1. Okay. Then the next thing here is, if you remember the labels, we said yes or no, right? Or we said stage 1, stage 2, stage 3. But then we said the computer doesn't understand these. All it understands is numbers. Now, how do you convert this to numbers? How do you convert Sunday to Saturday in numbers? 0 to 6 or 1 to 7? Yeah. For the guys who use arrays, 0 to 6, right? So what you do is this thing, say, okay, I have two things here, yes and no. For the first example, this is 1, this is 0. The second example, this is 1, this is 0. Third one, this is 0, this is 1, right? And the jargon for that, the technical term there is one hot encoding. Only one thing's hot there, right? They call it encoding because they're transferring stuff into this new format. So that's what this guy is doing out here. Okay, I think the Y test one is what they're trying. Now, suddenly you'll see X train has actually 60,000 samples, and each one of them is a 28 by 28 grid. They call it a matrix. Actually, it's got 3 dimensions there. It's like a cube with lots of numbers. Okay, so read up on linear algebra if you're really interested in this. Scalar, vector, matrices, tensors, and you'll get this. But basically, this is some way of feeding all of that data in a structured manner to the next piece, which is the AI model. And this finally, after an hour and a half, or an hour maybe, you get to see some model building, the actual model that's being built. And it's not that difficult, right? So in this case, you sort of build a model layer by layer. You need to go into each of these to figure out what those layers do, but that's how it's done. So I just wanted to give you a glimpse of how do you build a model, and then finally say compile with all of these parameters and stuff like that. Eventually, what you're going to do is you train it. If you see batch size, epochs. So when I send in a whole training set and the model's seen the whole training set, that's one epoch done. But the model has some learning rate. We tell it, don't really learn everything in one shot, right? Because you might go wrong. So that's where we sort of reiterate and we sort of send in the whole batch again. So when you finish one whole training set, that's one epoch. In this case, I think he's doing 100 epochs here. Okay. The model.fit is the actual thing that internally has a whole bunch of sort of neurons or small computation units that it can sort of learn. And what it's going to do is it's going to keep changing those values to see if the input, because of this, can actually match the output, right? So in simple terms, that's what it's doing. So to sort of figure out, oh, this thing didn't work, we have to shift a little to the right? So it's going to do all of that. Finally, it's going to get it, right? And that's where you'll see all of these training things happening. So it says on epoch 1, my validation accuracy, right? That's something you want to test out, went to 98%, right? And which is why I'm saving that model. And the next one says, oh, it's still improved. I'm going to save that model. It doesn't save it here. So there are ways by which you could say, if the validation accuracy increases, only then save, right? So you could do all of that fancy stuff out here. And it's just going to keep running the epochs. Loss is how off track are you from your goal. If loss is 0, then you're perfectly there. If not, then you're sort of trying to minimize that loss, right? Which is why AI models are a lot like investment bankers or businessmen. You want to minimize your losses, and that's what we sort of do all the time on AI modeling. Okay, so this thing sort of keeps going on. At the end, you run it on the test set, and that's the accuracy that you get, 99.2%. Which means it's not 100% accurate. You will get some pieces wrong, but majority of the time you'd be okay, right? So now you've seen some code. Not too difficult, right? I mean, yeah, you'll have to go in and figure out various layers and what they do, but that's not too difficult either. And remember, this isn't, this is just a kickstart session. So you have all the basic blocks with you. Now you could go and learn about it. You know what's a train set versus a val set versus a test set. You know what are epochs, what's learning rate. You know, build those small units of understanding, and then suddenly all the pieces would fall in place. Okay, let's actually get back to this guy. So we'll quickly run through this. What we are doing here is we talked a lot about the input and the output, but what we are really doing is input. Once we collect it, we process it, we sort of put it in the right shape, and typically what happens is you'll get something like this. So you'll have sample 1, sample 2, right up to sample n, and here you'll have various features, right? So those could be pixels, it could be words, it could just be features, basically just attributes, right? So we said if you want to do the electoral thing, you want to collect stuff for citizens, this thing might be what the age, the gender, stuff like that, how many times they vote, lots and lots of information that you have. So those are just called features, and towards then you're going to have labels. So it's going to look something like this. All of your X fitted there, and then the Y out there. And then you split that up into X train, X val, X test, and similarly the corresponding Ys. Okay, and a pictorial representation of how a neural net looks. So you sort of know the previous X and Y. That X goes in here, each row at a time. Right? So if you sort of head back to this guy, that row here, all of these features, right, have to be fed into the neural net. So you sort of feed all of that information, it travels here, it's going to get some output. You match this with the labels, it's going to be way off track. That's your loss, right? Again, go back and do it. And the neural net's programmed to sort of minimize that loss. The more examples it sees, it's sort of going to do that. This is how it's actually done. There's a good sort of demo of this. I can actually bring this up. When you say learning, what is it doing, right? So this is a very basic case. If you've heard about linear regression in pure machine learning, not necessarily deep learning, you could use it anywhere. So initially, so if this is one of the features, X, right? And that's the output, Y. So what you do is, let's say square feet area and prices, right? So this is square feet area and that's prices. You plot lots and lots of examples, right? So this is how it looks. That's what it is. And now you want to learn a function, like we did that, right? 2, 4, 3, 6. We learned a function internally. So the model has to learn a function, and that's what it's trying to do. And the way it does is loss bahut zyada hai, way off track, okay, less, until it comes here and converges and says, okay, I'm happy with this now, cannot improve over that, right? So that's like the loss thing that works. Okay, how did I get that thing? I thought it was nice to just show this code because it's not that code intensive. If you know what you're doing, there are lots of libraries that give you all of this packed up, right, packaged, and you can just use the right things. So all of that code fits in here. You just go through this and it concretizes what we just did with the other example. So this is on scikit-learn, which is another library. It gives you a nice data set, stuff that you can directly load. So your fetch data, prepare data is all done here, right? It's going to create its X and Y, create a model, split up the train, test, and val sets. I don't know if it uses val here. I'll increase the font on this. And then finally, it's going to model.fit that, get the results, and predict it on that, right? So simple enough. Same steps, syntax might vary, but that's okay. Okay, so a lot of people talk about underfitting and overfitting. We also said that, right? If you showed everything on the training, it might actually go out and not perform any better than what it was doing here. What do you think is underfitting and overfitting? Like, forget about the jargon, like conceptually.
Underfitting is probably way off. Over is when it's too stringent and then you might have
Overfitting has learned too much. something comes in really good feel.
Okay.
Because it has learned
Yeah.
itself so much.
So what are we saying? Who is overfitting or underfitting? What is underfitting? The model, right? So the model. I'll give you a couple of examples that will really concretize this for you for life, right? Have you seen someone who's not smart enough, capability wise? Call them Buddhu, right? Can't learn much. Itna hi capacity hai, itna hi karega. That's underfitting. Okay. Then there's a proper fitting, which is we guys possibly. Okay? You can classify me under underfitting. But then the third one is overfitting, and that's not over smart. It's ratta, learn by heart. Okay, you showed examples. It's learn the examples only. It cannot perform on other things. But if you ask it that, it's going to give you the whole answer, right? Do we want overfit stuff? We don't, because it's not going to perform in real life. Do you want underfit stuff? It's not going to perform anywhere, not even in the training, right? So that's what this is. Now, let's forget this part. Let's take this. So let's say I have two features, x1 and x2. Okay, you understand features now, right? Some inputs, and the samples are put up here. Each of these x and zeros are actual samples at that value of x1. So let's say this one has value this for x2 and this for x1. Okay. So similarly, there are lots of these guys with various values of x1 and x2, and depending on what their label is, it's either an x or a 0. Yeah, so it's a 0 or an x based on what it is. Let's say you are classifying fruits, right? So oranges are x and apples are 0 on some features. We don't care what those are right now. What you want to do is draw a line that separates out these two classes. Okay, that's the function that you are learning. So if you don't have too much capability, you're just going to draw a straight line possibly, and it's not going to fit too well, as is this case. Right? You see a lot of x's there and here. Now, if you are doing, just memorizing the whole thing, not really learning the pattern, but the next time I ask you 2 and 4, you said yes. But if I ask you 6 and what, you'll say, no, I haven't seen that. I only know 2 goes to 4. Right? So those are these pieces. It's actually learning each specific example, drawing the decision boundary like this, so that if anything falls here, that's okay. Falls there, that's okay. But it's not really generalizing it well. Okay? Memorizing. So that's overfit. And this guy is sort of nice, although he missed out a couple of X's, but for most part, he's got a great understanding of how to separate the data, and that's sort of a good fit. Okay, so that's what that when you hear these terms saying these guys underfit, these guys overfit, and we're sort of there are also terms like bias and variance, and they're related here. So this guy has a high bias, too rigid as someone said. That guy has a high variance, too flexible. Like it's just fitted around the whole input. Okay. Okay. I'm probably going to skip this in the interest of time, but I'm quickly going to show you some stuff around what's put up here. So let's say you actually had some parameter here and here, and based on the values there was a loss, right, which was sort of marked here. Okay, so this is sort of the shape of the loss function. Okay, which means if you have x1 and x2, actually these aren't x1, x2. Okay, there is something called hyperparameters. Parameters, model parameters, and hyperparameters. Model parameters are internal structures that it's going to learn through the neurons that I told you, right? They learn some stuff and things like that. Hyperparameters, something about that. How many layers do I have? Right? How many, what's the learning rate that I put in? How fast should I learn? Stuff like that. That's not within the model, but how do you construct that, right? So you could sort of deal with that, and those guys are called hyperparameters. So imagine having, multiple learning rates and layers, and then trying to see if I actually do this part, how does the model work? It's got this loss. If I do this part, what does it have, right? So you can sort of play with some of that. In this case, what happens is you want to minimize loss, right? Have you heard of gradient descent? It gets talked a lot, right? Though that's like the algorithm, backpropagation, gradient descent. Internally, basically, what all of that is doing is trying to learn how to minimize that loss so that your inputs match the outputs. Okay, we'll leave it at that. Uh, After you have the model, we said we have to evaluate. How do you evaluate? Accuracy is just one way to do it, right? Okay, so let's actually go through a couple of things here. Have you heard of something called precision and something called recall? Yeah, okay. Can someone tell me what is precision and what's recall? You could look up and give an answer. So let's say we have some examples, okay, and that's the actual example labels. Some of them are positive, some of them are negative. You can take the cancer case, okay. So some examples are positive, they do have cancer. Some of them are negative, they do not have cancer. Now we predict stuff on those, right? And based on that, depending on what you tag positive, you sort of put it there. Right? So if I say this guy has cancer, if he really had cancer, I put him here. If he did not have cancer, I put him here. Okay? So you get something like this, which is called a confusion matrix. It's not very confusing if you know what it does, but the jargon is confusion matrix. And what it does is basically say, look, this is what I predicted, yes and no. And this was the actual yes and no. And you fill in those values there. Right? And that helps you sort of understand, go beyond accuracy, sort of understand how do you do on precision and recall. I'll give you a funda around precision and recall. Okay? So let's say we've got two guys. One is a gambler, okay, and the other guy diffuses bombs for a living. Okay, fair enough. Now, precision is basically taking one shot and getting it right. You cannot go wrong. Right? So when you do something, when you predict something, you want to be right, else you don't predict. Fine? So if you catch a cancer case and you say it is cancer, it better be cancer. Right? And then recall is where you don't mind being wrong, but you want to make sure that you collect everything, all cancer cases. Right? You don't want to sort of mess up. If some of them didn't have cancer and you predicted cancer, that's okay, that's an overhead. But you don't want to miss out on anyone who had cancer that you couldn't catch. Okay, there's a sort of a difference between the two. So now here's the question. What do you think is important for the gambler? You know, precision or recall? Precision. And then what's important for the bomb squad? Precision. Okay, all right. So you're saying both of these are important. For the gambler, why is precision important? Assuming he's betting all his money on that every time. The first time that he gets it wrong, he's out of the table, right? So you want to be sure that you have sort of, so in the casino, there might be 1,000 bets being put, but he doesn't care. He wants, he places 3 bets, he wins them all 100% precision or 100% accuracy. On the recall guide, let's say there are like, 5 bombs that had to be defused, right? What would a high precision guy do? He would go to 2 sites because he's very confident the bomb's there, go there and defuse them. And then he says, I have 100% precision. My job's done. Is his job done? No, you've got 3 more bombs to defuse, right? But he says, I might actually go wrong. Like, to get those 5 bombs, I might have to go to 7 or 8 places. So I might be wrong 3 times. But that's desired of that particular objective. Right? So you go to many places, but make sure that the recall, make sure all those positive instances have been collected, right? So depending on your use case, you will need to sort of figure out what's a good metric to go by, either precision or recall, right? And then, as is the case in most cases, they just build a hybrid thing. There are things called F1 scores, ROC and area under ROC. There are some examples around it. You can read that up. But basically some way of saying, look, I want a fine balance between precision and recall. So you could do with something called an F1 score, which just sort of combines both of them, right? But you get the fundamental difference between precision and recall, right? Because a lot of data scientists that I interviewed way back in 2015, and when I was sort of talking to them, they were doing data science for like 3 years, but the only thing they knew was accuracy. Like when you say, but in this case, like if it's things that you don't want to leave out, do you really need high accuracy or do you need high recall? And they didn't know what recall was. So yeah, so keep this in mind. Okay, so hopefully we've covered enough to give you a flavor of what a practitioner does. I know this is sort of exaggerating, saying I don't know how to build AI, but in the given time frame, that's the best we could do. The last part is around kickstarting your AI journey. And I just want to talk a bit about this. So, is there anyone who wants to do anything different than what's put up here? Because I might not, my recall wouldn't be 100%, so I've not caught all cases. But so you're either going to use AI at work, you're trying to get a job in AI, you're trying to build your own AI product to start out, you want to teach AI, you want to run an AI lab. Covers most cases? Yeah, okay. So how do you go about doing this? I think using AI at work, you're fairly covered with that. Based on the examples that we did from multiple verticals, you have a fair bit of idea of how to do supervised learning, and you know what the other types are, unsupervised and reinforcement. So there. Getting a job in AI. What I'd suggest, is there anyone who's trying to get a job in AI? Yeah, okay. So the way you go about doing this is pick up one particular thing, right? So out of computer vision, natural language processing, or just statistical machine learning, just pick up something. So in regular terms, pick up your input, either images or videos, or text, or numbers, and stick with it for some time. Okay. So if it's images, it's going to be convolutional neural nets that work really great with images. If it's sequences, then recurrent nets work great. So pick one thing and specialize in that. Do some basic examples. Study it for like about maybe 6 or 8 weeks, right? And with today's knowledge, you should be able to sort of ramp up fairly quickly on all of the basics that you need for that. Plus, go and do some advanced examples. Then apply for your job. And when they ask you, well, apply to the right companies. Right? If you apply to an NLP company with computer vision skills, and if they're not looking for that, you might get rejected. So just go and try and figure out companies that work in specific stuff in AI. Right? So they might be doing computer vision, learn about convolutional neural nets, just stick with it for some time. The other stuff is the same, whatever we went through, right? The inputs, the outputs, training, test, validation, final law, you'll get all of that. Plus the whole strategy thing on how to spot opportunities. Nothing changes. But as a practitioner, if you're sort of looking for that job, then please learn, one of these things and learn it well, and then apply for it, right? If you're trying to build an AI startup, the main key constraint here, as we sort of figured out, was the data part. Right? It's never the AI model. So try and figure out what's the space you want to work in. So let's say it was one of those disaster management or electoral things. Try and hunt for that data. Now you might not get a lot of data, but that's okay. Start with whatever data you get. Maybe build a model. It's going to come up to maybe 60% accuracy. That's fine. One of the ways you could address that is don't try and predict everything. Right? Break it down. So for example, if you want to predict cancer by the stage, don't do that right now. Just predict yes or no. Right? Easier problem. Once you have that data and sort of go through, then what you do is say, okay, I have enough data. I'm also capturing the stage of cancer. Eventually, you'll get to a stage where you can now sort of build a model which is multi-class and it can do this. So sort of do it in an iterative approach, but focus on your data collection strategy because that's going to be the IP. It's not going to be the model. Okay. If you want to teach AI, I thought I should put it in because it's in the answer. So if you want to teach AI or if you want to teach AI to your colleagues or your friends, read up a bit on, take the whole top to the next level now, a whole bunch of basic building blocks. Now try and work out examples end to end, even for the practitioner, right? And then you might want to read on some theory as well, in terms of the math behind it, because it depends on whom are you going to explain it to, right? I have some fun stuff towards the end and you'll appreciate it later on. If you want to run an AI lab, like me, I don't know why you want to do that, but that's because you want to help a lot of other pieces, other people sort of implement AI, and you are sort of sector agnostic. You don't care if you're doing it for, healthcare, manufacturing, you just love the whole fact that you could help so many people, right? So that's where I suggest you actually, instead of going breadth-wise, depth-wise like the job bit, in this case, you might just want to go breadth-wise, like get the overall exposure across what happens in computer vision as opposed to speech recognition, as opposed to NLP, right? And even if you understand it at a business level, it's great because then you could just go and talk to companies and tell them where to apply AI, right? Okay, so This is a cool graphic made by someone. Again, in source, there's a link. But Andrew, how many of you guys know this guy? Andrew, a lot of you. Have you heard of Coursera?
Yes.
Yeah, so he's the founder of Coursera. He's actually the guy who put up the first machine learning course, the one that I did way back, and it was great. And he knows a lot of stuff. He's worked at Google, at Baidu on their search algorithms. So when it's coming from that guy, obviously he's sort of been through it, right? And he gives us the gist there. So what we can learn is, one of the things says is anything that a person can do in 1 second is great to be sort of done by an AI. Why? Because there isn't very complex decision making. It's a yes/no thing or a stage thing, right? So that again, all models are wrong, and he says that too, right? So he says, this isn't true always, but it's a good sort of guiding light on what all could you sort of automate with AI. These are some of the things that we went through on the supervised learning bit. One of the cool things here is this part, right? So collect some data, build your product, get the users, they'll generate more data, refine your product, get more users, get them to generate more data, and you sort of go into this virtuous cycle. And you need that if you are an AI product company. Okay, resources. So there are a whole bunch of resources. I couldn't put up all of them, but I've put up stuff that I've sort of studied myself or been exposed to. So deeplearning.ai is Andrew's sort of link, and you could sort of go through that. The other is fast.ai. Have you heard about Jeremy Howard? So have you heard about Kaggle?
Yes.
Right. So he was sort of a winner on successive challenges, right? And then Kaggle sort of took him, and he sort of also has this company called Analytic. I'm not sure if he's still there, but they used it in healthcare. What he's done now is he's launched fast.ai, where there are a couple of courses, right? So stage 1 and stage 2 courses. And if I had to single out like one resource out of all of this that you should see if you're serious about implementing AI, like being an AI practitioner, it will be this one. So go through those courses; they're amazing, and he sort of simplifies it pretty well, and but without dumbing it down. So he sort of gets to the math and stuff like that behind it. On the general piece, Quora. So just go out, and if you sort of a good thing that I do is if I don't understand something, I just say, what's the intuition behind, and then put that X, right? And someone on Quora who's much more smarter would actually have like an intuitive way of explaining it, right? So try that out. Google Images, why would I list it there? Apart from the graphics and stuff that I sort of picked up. There's one cool thing with Google Images you could do, type animated, right? In tools, you could also sort of say, you've shown me images, but now filter it by type. I want to only see animations. So try and do that on the concept that you want, and it's going to bring up great visualizations, and you could sort of then go through that and study those links that talk about it. Quick way to do it. The hacking part, room key, yeah. I've put up some links on the blogs. You could also follow some of these guys on Twitter because they keep posting what's cutting edge and stuff like that. Towards Data Science is a great sort of site. They keep publishing a lot of articles that I read. There's a YouTube channel called 2-Minute Papers. Have you heard about it? So what that guy does is he looks at current research and in under 2 minutes explains it to you, right? So that's where you'll see a lot of what can AI now do, what sort of inputs is it taking, and what sort of outputs is it generating. You'll see a whole bunch of those in 2-Minute Papers. I recently found this resource thing, right? Leadingindia.ai. They have a whole bunch of collection, right? Anything that we would start collecting now is probably already covered there. So just go there and see, and they nicely categorized it by books, by courses, by blogs, articles, various things. So please go through that if you're interested. Books. When I was pretty confused, I was very confused initially on what is data science, and all. At that time AI wasn't as popular, but data science was. And we used to use a lot of data mining at Tesco when I was there. And that's where I think Data Science for Business was a great book. It's written by a couple of professors. And it just gave me all of those fundas, like the basics that I wanted to understand what's going on. So that's where I learned about precision and recall, and with great examples. So if you sort of are one of those book-loving guys, go for those books. The other one's a deep learning book by the guys who sort of introduced deep learning in around 2012. So that's another great book that's written, and it covers deep learning specifically, right? The stuff that Good. On coding, Kaggle, as I mentioned, they sort of call themselves, initially it was just a competition platform, but now there are something called kernels. And kernels are stuff that people have coded up and put up there as examples for you to study and go through. So that's great. They also have a lot of data sets. A lot, I mean a lot. And by whatever function you want. So retail, healthcare, you name it, and they've already got it. So go through that. The next two libraries you could use. Start off with machine learning if you're not too hell-bent on doing just deep learning. So start off with machine learning. It's easier to pick up. Try and we saw one of those things, right? The linear regression one. That was a machine learning example. So go through that. Scikit-learn has great resources and examples on that. The other one is Keras because they have lots of examples as well. The reason why I use Keras is, in fact, FastAI has also launched a library. Underlying, they use PyTorch by Facebook, I think. And then on Keras, the one I use is TensorFlow behind. So these are great abstraction layers over the libraries like TensorFlow and stuff like that, right? On the base libraries, you have great abstraction layers because they'll help you uniformly do your stuff. You don't have to learn syntax every time there's a new library. So that's why I sort of like using Keras. And that's just a graph of what's really popular. There are lots and lots of frameworks. So TensorFlow is really popular, and then it's followed by Keras. Okay, good. So you know enough to kickstart your journey, I'm guessing. Was it useful? Yes, no, you can be honest. Yes. Okay, so best of luck for that. And if we have a few minutes, I have some fun stuff to show you. The first one, cars. If I asked you to discuss cars, how would you discuss cars? Talk about color, mileage, safety, speed, model, brand, automatic, gear. Good one. Okay, so that's how you will discuss, right? Saying, oh, this one has a great mileage, that one doesn't. Okay, great. Imagine I actually go to a car repair shop, and a whole bunch of guys there, and I ask them to discuss cars. What do you think they'll do? They're going to discuss it at a level of assembling the engine. How do you repair if something's broken? Okay, so that's the second group. Now I go to the third group, which is companies that actually manufacture these engines, right? The parts. What do you think? How are they going to discuss it? They're going to try and figure out leading research, come up with engines that give better mileage, maybe some chemical combustion stuff that happens inside. Right? So now you see there are varying degrees of scope that people discuss stuff at, right? These three are important. In the world of AI, if you are a business person who wants to sort of do AI, you want to discuss it at the first one that we did. What's my input? What's my output? Where can I use this? Right? How can I get better stuff out of AI? If you're an AI practitioner, you want to see how do you assemble these parts that are there, TensorFlow, Keras, a whole bunch of them. How do you put all of that together and build that car for the business guy to use? If you are Google or Facebook, then you're coming up with these libraries and cutting-edge research, and you're trying to figure out, what's NVIDIA, what's the best thing next in GPUs, and stuff like that, right? So these are different perspectives. It's the same elephant, you're just seeing it differently. Ties back to what we showed. Yeah, okay, great. So that's about the car space. The next one, have you read about this article? It was in the news sometime back. So what happened was everyone got spooked, okay? And the way they got spooked was they said Facebook's AI robots started talking to each other and in a language that humans couldn't understand. So they had to shut it down. Seems spooky? AIs don't take over the world? Yeah? Okay. That's what they sort of actually said. And none of the Facebook dev guys actually made any sense of that. So they said, okay, let's shut it down. We don't know what's happening. The media covered it and they said AI has found its new language that humans cannot understand. I'll show you how I think of it. Do you understand it? But are you spooked? Do they have a devious plan to take us over? All right, you get the point. So I mean, now that you sort of look at what we learned, you gave it some inputs, it started giving some output. But that guy's output was tied to this guy's input, and this guy's output was tied to that guy's input. So they used to sort of keep getting these inputs, and they just gave out output. I'm pretty sure that guy, it's not sentient, but it didn't even know who's consuming the output. Forget about forming like a devious plan, right? So when you read these news now, you've got enough ammunition to deconstruct, right? So that was the piece I want to cover here. And then the last part. Who do you think is going to win this? And I'm going to end that. I won't bore you beyond this, but let's just finish this one last exercise for today. So there are like a whole bunch of minions here. And you know who these guys are? The Avengers, mighty powerful guys. Okay? Who do you think is going to win this? Be honest. Minions? Okay, so contrarian approach, great. Okay. I want more answers. I know there can be only two, but think about what I'm looking for. And imagine all of the mental models that we covered. Who's going to win this? Both? That's politically correct. Like, that's not taking sides. Shouldn't.
Depends on who they are fighting.
Yeah. So can you repeat that?
Depends on who they are fighting.
They're fighting, okay, depends on what they're backing or whom they're fighting. Each other. Okay. So there is like this competition, and that's group 1 that's participating, and that's group 2 that's participating. Who do you think is going to win? Avengers? I love them, and they might win most challenges, but not the one that I'm about to sort of give them. I'll tell you the challenge, and it'll make your life easy. Okay? The challenge is it's not fighting each other, because you know who's going to win there. But what if I actually had 1 million additions to be made, and all of the additions were single digit? 2 plus 2, 3 plus 4, 5 plus 8, right? I have a whole bunch of these to be made. Who do you think is going to win that? Minions, larger in number. Each one of them are not as strong as those guys, but they can actually compute easy stuff, right? So you think these guys will be way faster than those, right? In deep learning, whatever we sort of figured out, right? I told you that box which has to compute all of this stuff, or if you play games, when the sort of main person on the game role play shifts, the whole landscape changes. You've seen that? So that's a whole bunch of computations, lots and lots of computations to be done, which is why they use a GPU. Have you heard of a GPU? Yes. Right. So no matter how powerful CPUs you've got for deep learning, GPUs are typically faster. And with my experience, they were 50x faster, but I know that people say they are around 50 to 100x faster. Right. So what can be done in about 50 days can be done within 1 day here as opposed to there. And that's because it's got these millions of computations to be done, and the GPU would actually have, let's say, 3,000 cores, right, on which it can compute stuff. This guy, the CPUs, no matter how powerful, would have like 8 cores, 16 cores, maybe 32 cores, but you're not going to put that range. But they can do more powerful stuff on each core, but we don't need that. We need these small things to be done, right? So which is why you'll see a lot of articles talking about how deep learning needs you to have a GPU. And that's where one of the resources said Colab that I didn't cover, but that's Google's way of providing you free GPU access, unless you want to run it for like hours and hours, in which they sort of preempt you, but you could sort of play with stuff, right? So you'll find free GPUs online on some of these resources, try Colab. But this is a concept that I just wanted to sort of end the talk on. Okay, all right, that's about it. Yeah, so that's me sort of getting this off. If you have any questions for me, let's sort of kick off the Q&A. I need some water. Okay, so if you don't have any questions, that's fine. Just give me some feedback. How was today's session? Was there something you liked, something you learned? Or was it a complete waste of your Friday? Anyone? Yes.
The activity part that you did was very good.
Okay.
I could relate it to the next supervised learning.
Awesome. Yeah,
That was
I'm great at work. I took a shot and I hope it would sort of work out. Yeah. I think in designing the talk, the main thing was I was going to expose you to stuff that you never have seen possibly. So I wanted you to trust me on that to finish that. If you had walked out, then it would have been a share for me. But once you finish that, then things get put into perspective and you see what is it that others are doing. And then now you know a lot of stuff, right? You know about supervised, unsupervised reinforcement, you know about training and the way you sort of construct these models. You know about underfitting and overfitting and in a way that you'll never forget, possibly. And you now know a difference between GPUs and CPUs. Trust me, if you go and talk with some of these practitioners, right, or people who are working in AI, and I'm not saying all of them are like that, but I meet a lot of folks, and a lot of time because there's such a craze around AI, you'll find people are just sort of going after just doing some AI for the heck of it. They don't really get it. I am quite confident that you now get it based on today's. Okay, any other questions? Yes. I can barely hear you. I can pass you the mic. Oh, Google's AutoML. Okay, so what happened now is you want a lot of AI folks to help you build that magic box, and what happens is apparently there aren't many who know how to build that magic box. So what Google's trying to do, and not just Google, Keras has an AutoML as well. It's called AutoKeras. So what they'll do is they get an AI to generate a model. And now suddenly, you will find discovery saying, oh, AIs that can generate AI. We're doomed. Not quite, right? So for that, you need to actually build all of the inputs. You need to feed it all of that. And then what it's going to do, I talked about hyperparameters, right? How many layers to put in, what sort of stuff to put, which model to use, how do I construct it? You can push in some options and tell the engine to sort of build something that works. And it's going to run and find multiple things and then finally get you that. So Google's launched AutoML. The open source version of that is Keras, which has an AutoKeras. And I think some of the easy parts will just get automated. Right? So you give it a lot of images and put in labels and just send the AutoML to work, and it's going to come back and say this is a model. Right? So AI is a great tool, and you're going to see a lot of direction in which it's going to get used. Does that answer your question? Okay. Right. Were you looking for something specific?
How is it going to shift the dynamics in job opportunities for ML engineers?
Ah, okay.
Yeah.
All right. I see why you had that smile after I answered. So, what's your name? Sorry? Shrishti? So Shrishti is saying, look, should we really be worried? Because if AutoML and Keras comes in, do I have to actually have a practitioner job? Because some of it's going to get automated, right? If you're actually really good at building AI, I can tell you this, it's not easy to construct the inputs, right? Because that's where a lot of thought has to be put in on what sort of stuff do you build. And some of the modeling part is pretty mechanical right now. And basically, initially, that's where all the creativity was. But for example, finding learning rates or finding optimizers, various pieces of that puzzle are getting solved. And they're saying, okay, so this is just another component, which is why everyone reiterates that data is where your IP is, because all of these models are just going to be around and you could just build one. Right? So you won't be out of a job and neither will I. So.
Data is all.
Yeah, just collect some data. Okay, anyone else? Yes, please.
Yeah, so in addition to what you said, now AutoML is the modeling part of it and machine learning, building the model part. But I heard that, and I've seen some of the blogs wherein they're trying to have that data processing feature, identification, also automated.
Right.
And that is the feature set kind of thing.
Yeah. So we're actually building one of those platforms. But I can tell you this, that there will always be, so this is how things worked out when we talk about AI as the new electricity. When electricity came in and you had machines, some of the stuff that was getting done, which was labor intensive, right? Those were those kinds of jobs. And then things transformed into completely different types of jobs. Right? So you had knowledge workers and stuff like that later on. You had machines and people who could operate those machines. So I'm sure AI is going to disrupt. There's no question about that. right? And not just this, you might find someone who might say for a specific problem, you don't need to go anywhere. I'm going to automate the whole end-to-end pipeline. It's around the corner, like in some years or some time. But it's going to bring in some ability with it, and then opportunities will be created based on how you sort of leverage those abilities, right? So there will be transformational jobs, or you'll see more entrepreneurs doing stuff. A lot of people collecting data, possibly. So it's going to be fun. Okay. Any other questions? Yes.
So there is this whole movement of Make in India, and a lot of entrepreneurs and startups coming. So my question is related to how do you think with the new startup and the companies which are coming up, how much of AI is really essential from your perspective? Because this whole hype about
You don't want me to answer that. so
what is your perspective? You can say.
So there is a law. I think it's called Stuttgart's law or something like that. Okay, so we looked at 80-20. There's another law called 90-10, and it says 90% of everything is scrap, like not worth it, right? So I think I hint to the answer. Okay, so let's be candid. So I've worked with a lot of folks who want to use AI, who are practicing AI, and who are trying to get into AI, right? More often than not, I think because there is so much buzz around AI, everyone's just saying we do AI, right? If you look at data science, like sometime back, that was like the main, hype. Now it's AI, and there might be blockchain on the corner. But that's where. So what is data science, right? It's about any science you apply to the data, based on how we define stuff, break it apart and then apply. But actually, data science was quite intricate. Like you could apply some of this, do analytics on that. But when you sort of say data science and it gathers a lot of buzz, suddenly people who are just playing with additions on Excel sheets were tagging themselves as data scientists, right? So I'm a data scientist. What do? Is that I compute sums on the Excel sheet. You cannot refute that because, well, technically he is playing with data. He's sort of doing some science there. He can possibly be tagged a data scientist. So there is going to be that full spectrum, and you'll see that in AI as well. We see a lot of companies who have very basic analytics, and they call themselves core AI companies, right? But so that's always going to be there, irrespective of what field it is. Doesn't have to be AI, but which means there's a great opportunity for you guys. I can assure you that based on all of this, if you weren't sleeping and if you gathered this, you are way ahead of the game, right? This is sort of a max punch, the 80-20 rule. You've got enough bang for the buck for your time today. Once you go back, study about it, learn about it, go through this, talk to people. When you talk to people, you'll figure out that they throw jargon at you, but they don't really understand it. So if someone says, when I was interviewing one of these guys, I told him, at that time I didn't know a lot of data science. It was like 2014 or so. But I wanted to use it at the lab because I figured out it's promising. So I interviewed a guy and he said, well, I do data science and machine learning. I said, so what's machine learning? And he said, it's stuff that you could do and it could either be supervised, unsupervised. I was like, you just answered my question in another set of jargon and I don't get it. Like, fundamentally, what is it that you do? He says, we teach computers how to learn and they could learn a lot of stuff. And when I started talking to him, I figured out, like, I had much better fundamentals at understanding what's possible and what's not than that guy. Because that guy had been exposed just to one particular library and a certain set of problems that could be done. So the more you talk to people, you'll either learn or you'll sort of catch them on what they're saying. So please interact with as many folks as you can on AI and even read up a lot on AI. Twitter's got some great guys who keep posting on AI. So there's always going to, coming back to your question, there's always going to be a lot of noise, and which is why guys who can spot the signal are going to be in demand. So good times. Yes, sorry.
So in service-based industry,
yeah.
How to get the confidence of the customers that we can solve your problem. So what we faced in our company organization that not all the problems are solvable by algorithm. So some of the problems can be just analytics. You can just give some of the insights, accidental insights to the customers.
Yeah.
So before the problem is put on the table, how do you make sure that this is even solvable by ML?
Right. So Everyone gets the question? How do I know if I can solve this thing with AI? We don't. So try it out. Proof of concepts are a great way to do that. Even when we sort of work with companies, and if we aren't very confident of the space that they have, maybe for whatever reason, it could be the quality of data they've got. So we say, you know what, you should first just have a proof of concept, right? And try and see if things work, if you can actually predict what you want. And trust me, if you actually show them that, and they see it in practice and not in the PowerPoint presentation, they'll be much more likely to sort of give in and say, okay, why don't we try do a pilot? And we've got many pilots done that way where we've established confidence by showing them that it works. Stuff like that I showed you right now with the MNIST thing, where I drew stuff and things happened. If I show you a demo that I can possibly pick a project on handwriting recognition, if it was just a PowerPoint slide, you would sort of doubt me. But once I show you that, you have enough confidence to at least give me a shot, right? So you should do that. Okay. Any more questions? Are we done?
Questions?
I'll be around for some time in case you want to ask me something one-on-one.
Anything else? Okay, so just wanted to give you an overview. So this was the first meet of our chapter, WiMLDS. So we want to, take this chapter to a very long journey where we want to, skill people in very in-depth AI.
That was me button. Sorry.
So we are partnering with a lot of startups. So Tinkercraft, Prasad is from Tinkercraft, is one of the startups. Then IoT.in is another startup. On 7th September, we are having an event there where IoT.in is going to train students free of cost on a complete AI course. There will be certain criteria, and this particular one is for women entrepreneurs. So they want to train in their different platforms and technologies which are available. That will be a very formal training. And similarly, we are also working with big corporates who have AI products. Like Prasad said, right? NVIDIA, Huawei, Qualcomm, Intel, they have their own AI GPUs. So we are working with them where we will arrange workshops. We'll conduct half a day workshop or a 1 day workshop where they will train us on their platforms. Why would they do so? Because they want, resources available in the market who know their platform, right? That helps a lot because when there are more resources available in a particular platform or a skill in the market, then that's a big criteria for decision making. For example, choosing, that I'll use this platform because, more resources are available. So we are working with them. So 28th, we have our second meetup where we will have a speaker from IBM. Okay, and she is the part of developer community, and they might give us access to their licenses and platforms to play around and to go POC. So we will post more details on the meetups, but the overall objective of this chapter is not only to skill people in AI. There is huge shortage of resources in this field, and as Prasad said, it's like you talk to 10 different people, you'll hear 10 different things. So there is huge shortage of resources. The depth is not there, and it is a very vast field. So we are definitely working on skilling people on that. But in addition to that, we are working with startups and corporates to create internship opportunities, job opportunities, training opportunities, and we are also working to give us some platform where we can do proof of concepts and projects for these companies like IBM and all. And that will be an opportunity for you to learn. So please follow us on social media. We are there on FB, Insta, LinkedIn, and Twitter, and we will keep posting on the details of this event. This is just a start. We had taken a survey, and based on whoever had responded, we saw that 90% of the people were beginners, okay, and less than 3 years experience. That is why we thought that we will start with the first chapter with lot of basics, right? So Prasad covered lot of basics in simple language, which is easy to understand and relate, right? But going forward, as we go into details, as we conduct more and more workshops, we will try to focus on special areas so that you can learn certain things, right? And please take the benefit of this because we'll be working with very good companies. So if you continue, with this journey, then you will have that flow. Okay. So 7, IoT.in is having a workshop at Wow Institute. We'll be posting that on our meetup. And 28th September, we are having a speaker from IBM who will speak about quantum computing as an enabler for AI. So as Prasad said, computing, one reason AI has been there for 50 years, right? I mean, this concept theoretically has been there for 50 years. But why it is now, materializing, now why are we able to apply it? Because the computing power has increased, right? He showed you. So she's going to talk about that, and she's a very senior expert in this field. So please do follow our meetup and other media, and try to attend all the sessions. And if you have specific needs or interests or requests, please free to contact us. We also have a survey designed. How many of you have taken the survey today? So we have a survey where we are trying to collect data. As Prasad said, data is the most important thing. So we are trying to collect the data of our audience, which can help us, plan things better for you. So this was just our first startup. Thanks a lot for coming. I really appreciate, your time and patience. I think it's more than 22 hours. And I'll request Gayatri to give a small memento to Prasad. So,
Can I step down now?
hey, can you take someone's photo? Yeah, I'll take. Go on the stage. So we have some of the partners here, like Holistic Skills and TechSmart. So they are going to support us. They are our knowledge partners. They are going to conduct some sessions for us. We are also working with them.
Do you guys know NASCOM? I think, yeah, you do that. So we have got NASCOM certified courses at our center. Take Pune. Come and join courses as you wish.
And then we have other startups like IoT.in, Rabbit and Tortoise, if you have heard. And Rutuja is here. She's setting up a data science team in her startup. Rutuja, if you can just stand up. And she's going to be our speaker sometime. And Tinkercraft, Prasad is going to work with us. And there are many opportunities where people are looking for resources. They are willing to train them also, right? And you can work from home also, right? I mean, you can work. So there are a lot of opportunities to. So please keep connected with us if you are interested to pursue these opportunities. And special thanks to SICSR for sponsoring this venue for us. And all the volunteers, if you can stand, Meghana, Sudhanva, Sonia, Mudita, Gayatri, Nikita Gandhi, Nikita Jain, and who else? Rucha, yeah, Rucha, and Gunisha, Anushka. Rohan is there or is left? Okay, so these volunteers have really worked for last 3 months. We just started our meetup on 27 July.
Let's have a round of applause.
It's just 4 weeks. Okay. And I think it's a huge audience, right?
Yeah.
So thanks a lot, and I think it's very important that you help us with what inputs you need, and that will help us motivate to take this further. There are a lot of things. We are working with a lot of good companies. I'm talking to Samsung, Intel, Qualcomm, Huawei, Nvidia. They have their own GPUs, like Prasad said, and other opportunities. So they will be willing to give us training free of cost on their platforms. So we will be conducting half a day or 1 day workshops where you will keep learning. And I think the more you listen, the more you connect and network, you will learn more, because AI is not very old technology. It is new, it is evolving. So there is nothing much written about it, which some companies have done with experience, right? People who already actually implemented them. That experience you will get to know only through networking and